Good morning, everyone. My pleasure and honor to be here to talk about one of my greatest passions, space. I've been here now in Pittsburgh for a little over a year now, and I've worked very closely with my peers at Astrobotic to really help the lunar commercial space economy get started, which we're on the precipice of doing. So I'm going to take you on a journey. As Peter said, we're going to leave Earth and we're going to go to the moon, but we're going to do it in a different way than the way it's been done before. Yes, we've been there with 6 Apollo missions back in the 60s and 70s, but we're doing it in a completely different way now. So let's get started. So this is the portfolio of projects that we are working on here in Pittsburgh. And by the way, if you have not been to Astrobotic, it's 10 minutes from here, 1016 North Lincoln Avenue, North Shore. And we actually have, and I'll show you a slide later, a small museum called the Moonshot Museum that you can go to. And what's really cool about that is there is a huge window so that you can see us building the lunar landers that Peter was talking about. I'm going to show you more about. So we've got rockets. We have rockets that we fly out of Mojave, California. They're reusable rockets that fly experiments on board that can go up to 500 meters and land right back where we started so that the experimenters can get their data right away. In fact, I'll show you a cool video here shortly. Landers, we're building our second lander right now. I'll talk a little bit more about our first lander here in subsequent slides, but that's what that second picture is. We build rovers that will traverse across the lunar surface and do all kinds of different things. Power, Peter mentioned power. This is a concept that we call Lunagrid. That is a huge solar array that actually unfurls and it stays erect like that to gather the sun's energy and produce electricity, where we can offer electric power to various people who would want to send their hardware up there and basically drive up to one of our rovers or a lander. We've developed wireless chargers, so you don't actually have to plug in. You can just get close enough and we can transfer power to units. And we're really on the cutting edge and forefront of that. You know, Peter mentioned disruption in his talk. I'll use it in a positive way here is we are offering a disruptive technology development here with wireless charging on the lunar surface. We've actually tested it in lunar simulant, which is a simulated lunar dust, same characteristics as the lunar surface. And we've actually tested it out with lunar dust on the charging plates to show that we can do it even if it gets dusty. So it's pretty amazing. And then we also develop sensors. We're different types of applications for those kind of sensors, space-based sensors that can look either at Earth or we could use it in the lunar system as well. So lots of diverse technology that we're developing at Astrobotic. So here's Astrobotic at a glance. It was founded in 2007. We have multiple NASA contracts. We have contracts with the Air Force Research Laboratory and some other government contractors as well, or government agencies. The VTVL is the vertical takeoff, vertical landing, and I will promise I'll try not to throw out a whole bunch of acronyms. I've tried to kind of get that out of my mind after 23 years with NASA. And then we've got 3 lunar missions manifested, and I'll talk more about those. But as you can see, here are the pictures. In the left is Peregrine 1, which is one we launched in January of last year. And I'll talk more about that. The one on the right is our larger medium-class lander, we call it. And it's, as Peter mentioned, this is going to be the largest commercial lander to go to the moon at the end of this year. And that's in our clean room now being built. And then there's some various pictures. We have a mission control center there where we control our missions. So it's all located right here in Pittsburgh. And then you can see our technicians and engineers working on Peregrine 1 in the center there. And I'll show you more here. So there's our Pittsburgh crew on the left. That's the Astrobotic building I talked about on North Lincoln Avenue. Our clean room there with the Peregrine spacecraft sitting in it. And then on the lower left, this is another cool aspect. That is the Mojave Desert. And you see that big concrete area, and that's our LSPG, Lunar Surface Proving Ground. Well, what do we use that for in the middle of the desert, right? Well, using that vertical takeoff, vertical landing rocket that we call Zodiac, we are able to fly over this, and it's a simulated moonscape. And there are a lot of people that are developing sensors that need to actually practice using a simulated surface to refine the algorithms on their hazard detection systems and so forth, that they then will fly on their commercial landers to go to the moon, including us. A little bit more about our facilities here. You can see the huge clean room in the upper right. That was a picture taken a while ago where it's basically the skeleton of that medium lander that we're building now that you saw the solar panels on. We have a huge electronic lab facility there. We can actually do simulated environmental testing there. We can put our components through very hot temperatures, very cold temperatures, which we would experience in space and on the lunar surface. So we can do that all in our facility. And then, of course, on the lower right is our mission control system, or center, excuse me. So that's our facility here. Our other facility, as I mentioned, is in Mojave, California. And it is really in the high desert, if you've ever been out that way. There are a lot of aerospace companies out there that can do rocket testing because it's basically out in the middle of nowhere. I've been out there several times. It's really cool to see some of the testing that we do. You can see some of the rocket engine testing we do on the right side there. And of course, again, the Zodiac rocket there. So, real quickly, this is our leadership team at Astrobotic. John Thornton, our CEO, Dan Hendrickson, our Vice President for Business Development. We'll skip over me since you already know me now. Frank Perry, who is our Director of Engineering. Kind of an interesting fact about that. Frank and I came on board at the same time a year ago, and he retired from NASA after 33 years. And you would think he and I would have worked together somewhere along the way in our careers. We never met each other, yet we know probably 90% of the same people, and we just cross paths at like various different times in our careers. It's been crazy just, as somebody's name will come up and we'll just start laughing, oh, I know that guy, or I know that, yeah. So it's really good partnership between me and Frank on the engineering side. Mike Provenzano, he's our Vice President for Advanced Development Programs. Tamir Klav, Director of Business Office. Leanne Doomer is our Director of Operations. And Leslie, who is in the audience here, is our Director of People, and she's just recently came on board, is making a huge difference. So thank you, Leslie. Okay, so I'm not going to go in a lot of detail, but I thought, Peter did a really good job of summarizing kind of my background, but how did I get here, right? And it's actually hard to believe that I've been in this business for over 40 years now. I did start out on the space shuttle program in 1984. And I was a young engineer, and that is me in a clean room suit sitting in the cockpit of, actually, believe it or not, that was Challenger cockpit. That was one of the orbiters, as we call them, that I used to work on quite a bit. So that's in the pilot seat there, so pretty cool. And yep, I was in my 20s, first real engineering job. Peter and I were talking about this last night. One of the things that I really value is people's experience. And I spent my entire time for the first couple of years working closely with the technicians and the quality inspectors and learning from them about really how the job goes. You can do all the engineering you want, design it on, CADs, do all this good stuff. But sometimes when it comes to applications of that design, it doesn't work exactly like you designed it. And so I learned a ton from working with them very closely. And to me, it paid off well going forward in my career. So I've always encouraged, when I've mentored people, go talk to the people that are actually putting the stuff together and get them involved early. So I worked on the space shuttle program for a number of years. And then they're probably wondering, what is that second graphic with the Earth and all of those lines? Well, if you've heard of the Iridium satellite program, back in the 90s, Motorola developed the Iridium satellite. And the intent was to be able to talk to anyone, anytime, from anywhere on the globe. I will tell you that the technology development on the handsets, the phones, took a lot longer than what was planned. And in parallel, what was going on? Cell phone development was just going like gangbusters. And by the time Motorola got this cell service, the satellites launched, and the cell phones out, the cell industry had taken over and really beat them to the punch. So unfortunately, they didn't get to realize their original business plan. But the Iridium satellites are still flying today. The second generation is already up there. They found a niche market with the oil and gas companies for offshore oil rigs, with the Department of Defense. Quick story there. It kind of raised the hair on my neck because I didn't realize it. But fast forward many years, my niece marries an Army major. He served 2 tours in Afghanistan, got injured, ended up coming back. We meet him, as he comes into the family. We were talking one night at a dinner table at my sister's house, and we were talking about my background. When I said Iridium, he kind of perked up, and I was like, what? And he said, whenever we went out on patrol, we never left without our Iridium phones, because we could immediately air vac, an injured soldier out, or if there were reinforcements needed and stuff like that. And he goes, I can't tell you how many times without that radio, we would have lost so many lives, and we saved so many lives. I had no idea that the impact I would have had, decades later on that. So it's sometimes you never know what kind of impact or influence you have until something like that comes up decades later. So that made me feel pretty good about the fact that, I had some contribution to that. Then I moved on. I left the Kennedy Space Center, went and did the Motorola work for a couple years, came back to the Kennedy Space Center for family reasons, and got involved in launch vehicles and so forth. That's the Delta II rocket that McDonnell Douglas, then that became Boeing, used to launch, was a workhorse for NASA spacecraft. And then I was asked to help start up the Constellation program, if you're familiar with that. That was going to be our first return to the moon after Apollo. That went for, 4 or 5 years, and then when the Obama administration came in 2010, there was a review and said, well, this isn't sustainable, so it was canceled. Well, what came out of that was really what you know of as the Artemis program now, with the Space Launch System and the Orion spacecraft and so forth. So I helped make that transition over. That's me standing at the launch pad for the first Artemis launch that occurred, which was highly successful. And then I got into the science mission director at NASA headquarters. And so that's a real shot of the moon right there in front of the Earth from the Discover spacecraft that was launched, back a number of years ago now, that's still operating today. The sun, heliophysics, I was actually asked to head up one of the science divisions, even though I'm not a scientist, I'm an engineer. But I had a different purview, and our leadership was looking for a different purview to go in and kind of help solve some problems. And then I was asked to do a 1-year detail at the Office of Science and Technology Policy at the White House during the first Trump administration, which was a fascinating experience there. And then when we came back to NASA headquarters, I helped start a new initiative called Commercial Lunar Payload Services. And the reason that's important here is Astrobotic is one of the companies, one of the providers for this initiative that got started in 2018. Yeah. And I'm very proud to have gotten that started with a really good team at NASA headquarters and the NASA Johnson Space Center, and it's continuing today. And I've got a slide to talk a little bit about, some of the missions, or what we like to call shots on goal, that have already occurred and that we've got more coming. And then the last job I had at NASA was the deputy for the aeronautics research. And so this this was one of those where I got tapped on the shoulder and I asked, hey, would you be willing to put your name in to be the deputy for this aeronautics? My entire career had been space. And of course, my first question was, why would you want me to come over to do aeronautics when I'm doing space? And they wanted that different purview, that different mindset coming in to come into aeronautics and help. And so it was like the first day of NASA, right? National Aeronautics Space Administration. I thought, wow, what an opportunity to actually kind of fill the box on working at NASA. So I did that for 3 years and then retired in 2023 and then actually moved to Colorado. Peter mentioned that I did my road trip. That was my decompression time from all that time in Washington, D.C. And now I'm here at Astrobotic. So enough about me. Let's get back to Astrobotic. So this is the current flight manifest. I talked about Zodiac. This rocket has flown over 600 times. One vehicle, that same vehicle. We only have one right now. We're looking at building a second one. It's an amazing, amazing feat. And it's the team out in Mojave flies nearly every other week. We did last year, and our manifest is starting to ramp up again this year. Griffin, that is the mission that we're going to be launching at the end of this year. We're going to be taking a commercial rover made by a company called Astrolab out in Hawthorne, California. We're going to deliver that rover to the lunar surface, the lunar South Pole, and deploy it. And then they're going to do all kinds of different technology, maturation tests, and so forth with that rover. Also on that mission is our own Cube Rover 1. And that's a small rover that's going to have its own software on board. We're working with a Canadian company that is also going to test out their software on it as well. I've seen the flight model for it, and it's just pretty awesome. It's got 2 LED headlights on the back and 2 on the front so that you can see in the darkness on this, with the low light in the South Pole. And I've seen actual rehearsals for it, so it's pretty cool. We're also developing a second Cube rover, and this kind of ties into the lunar surface power I was talking about before, where we can actually spool out cables, power cables from the lander using our rovers, and then that wireless charger I mentioned could be on this rover. So we could go out for like a half a mile, maybe a mile, and then if other assets land in that area, they can come up and recharge. They don't have to carry all their batteries, and then when the solar power runs out to charge those batteries, they're dead. They can come up and recharge. So we're going to be offering power services on the lunar surface. And then on the right, Zogdor 1, really excited about this development as well. We are taking the technology we've learned from all of those reusable launches on Zodiac, and we're building a higher, more capable vehicle called Zogdor. NASA has been funding us to develop this higher, faster, more capable vehicle. It's going to be reusable as well. It will launch and return at the same spot. And the Air Force Research Lab is very interested in this as well. So stay tuned, because I think you're going to see some exciting things coming out of us here in the next couple of years on that. So let's talk about Peregrine 1. This was our first mission, and I won't go through all this list, but as you can see, we had a number of partners and payloads on this mission. This was our first lander. It was the first commercial lunar lander that was launched to go to the moon in January of 24. So, first of all, to get there, you got to start here, right? So, I mentioned earlier about the cold and the hot temperatures that spacecraft see in space, and particularly on the lunar surface. Well, you've got to test your hardware to make sure that it can survive all of that, right? So this is at the environmental test facility, and you can see the chamber, how big it is. The entire spacecraft on the right there goes in, they seal it up, and then actually fluctuate the temperatures from hot to cold to the extremes so that you can see if your hardware actually will survive. And typically, you're going to run into problems that you're going to have to fix when you come out of there, because there might be a few little things that you need to tweak. on that. Everybody goes through this. Every spacecraft, every satellite goes through this kind of testing. You also have to be able to survive the launch environment. Every launch vehicle has a different kind of environment. And when I say environment, the loads, the forces, the G's on it vary depending on the rocket. So you have to go through testing for that as well. And that's what you see here on the right. It's sitting on what they call a shaker table that actually vibrates, that simulates a launch vehicle as its engines start, launch, and you're going through the atmosphere to get to Earth orbit. And then there's also acoustic testing. Now, what's interesting about that is you're sitting inside an enclosed nose cone. We call it a payload fairing. But sound gets transmitted up through the structure from the engines when they're running, right? And it actually causes acoustic waves to happen in there. So you have to be able to survive that as well. That's what this setup is here, to simulate the acoustic environment from a particular launch vehicle. And in this case, we launched on the very first ULA rocket called Vulcan. So let's talk a little bit, and I'm going to infuse a little bit about AI here, right? So I would call AI at the nascent stage for spacecraft. We're not at a machine learning standpoint yet, but it's being looked at for longer duration missions, particularly to Mars and beyond for spacecraft, because it takes a long time to be able to send commands and receive verification that the spacecraft got your command and is executing it. Closer here to the moon, I'm going to talk about when you go to land on the moon, there's no just completely flat area on the moon to go land at, particularly in the South Pole area. So we have developed a hazard detection system for our lander. And so we test that out using that Zodiac vehicle that I mentioned with that simulated lunar surface out in the Mojave Desert. In fact, we just did that last fall for our Griffin mission that's going to launch at the end of this year. And what that allows you to do is refine your algorithms. It's more of the if-then that Peter talked about, where if I see this boulder and I determine it's this big, then I need to shift and move and not land on that spot. That's what's going on the automatic algorithms that are loaded onto the software into the lander. And that's what we're testing here. So here's the cool video of the actual Zodiac on one of the flights. Like I said, I've been out there for a handful of these and it never gets old. And that's all autonomous. It's not being commanded that way. It goes through its flight profile. So think about that, doing that over 600 times now. So I'm back to Peregrine, and I mentioned the Vulcan rocket. This is a picture of our Peregrine spacecraft on the left, about to be encapsulated in the nose cone, and then the launch on the right that occurred back in January 2024. Now, I wasn't on board with Astrobotic then, but I can tell you that I was texting John Thornton and Dan Hendrickson throughout this whole period too, because like I said, very passionate about this. I've been, friends with the other commercial lunar payload services companies as well. And since we got that initiative started in 2018, I still follow it with everybody. Here's an actual video of our spacecraft being separated from the Vulcan rocket once it achieved orbit. And this is a camera from the rocket looking towards our spacecraft, which is so cool. This is from our Peregrine spacecraft once it was in orbit and getting ready to go towards the moon. So, I mean, this is a real video from our spacecraft. It's just, to me, a beautiful shot of the blue planet with our spacecraft. And this is a really cool picture too, and I actually learned another thing from Olivia, our marketing and communications director today. So as you can see, that is the Earth with the little crescent there. But what's really cool is we developed a problem right off the start when we went up to pressurize the system to ignite our engine to go to the moon. And we had a valve that failed. and it actually caused one of our tanks, one of our propellant tanks, to get overpressurized and rupture. It didn't explode, it just ruptured, so it started leaking. And I got to tell you, the mission control team did a fantastic job of gaining control of the spacecraft. And then with a leak, they were able to fly this spacecraft for 10 days out to the moon, back around, back to the Earth before it re-entered into the Pacific Ocean. But we were able to gain control of the spacecraft even with a leak. And what they did was they positioned the spacecraft so that bar, that angled bar, is blocking the sun so that we could get this picture of the Earth. And it's just amazing. Credit to the team again for being able to control what I'd call a crippled spacecraft for 10 days. And we were actually able to turn all of the science instruments that were on board that were intending to do data on the lunar surface. They were able to get data the entire 10 days. And we know right now 2 principal investigators of those instruments have been able to publish peer-reviewed science papers with the data that they acquired. So we did get some success out of that, even with a crippled spacecraft. So didn't make it to the lunar surface, but it was an amazing mission. It was an amazing journey for 10 days. And I still, when I talked to the team that did it, it was just quite a learning experience, as you can imagine. So let's talk a little bit about the current shots on goal, as I called it, to get to the lunar surface. So back in August of 2023, India successfully landed their lander, Chandrayaan-3, and they had complete mission success. So obviously, the commercial companies here in the U.S. were like, okay, we got to be able to do the same thing. Excuse me. I've been trying to shake this cough for a couple weeks now. So I talked about our mission, Peregrine 1. We had partial success. We did not make it to the lunar surface. We know exactly what happened. We have taken many steps to ensure that our next lander will not experience the same problem. In January of 2025, and actually I think that was 24, was JAXA's SLIM lander attempted a landing. That's an actual picture in the upper right. They actually ended up upside down on the lunar surface. This picture was taken by one of their rovers that they were able to deploy once they got to the surface. My message is, it's very hard, even today, to land on the moon. I mean, the Apollo engineers made it look kind of easy. Very hard, very, very, very hard. So even to go back and do it now. Intuitive Machines, one of our, we call them competimates, right? We're all in this together to make this a successful lunar economy. They've had 2 attempts now. They landed the first time back in February, or actually last year on the first one, and they landed, but they ended up leaning against a rock. So they were able to get data, not all of the data that the science instruments wanted, but they were able to operate for a while. Firefly launched, and you probably heard about this in March. They were the first successful commercial company to land softly on the moon. They had a full mission success for 14 days. Peter mentioned about 14 days. A lunar day is 14 Earth days. A lunar night is 14 Earth days. So, Firefly Blue Ghost lander is now in lunar night, and that's when it gets extremely cold. They're hoping that when lunar day starts up again, that the solar panels will recharge and they might be able to turn it back on. Not sure yet. It's a very harsh environment, so we'll wait and see what happens. But they were very successful. Kudos to Firefly. They did a fantastic job. And then shortly after their landing, a couple days later, Intuitive Machines had their second landing attempt. They were able to land, but albeit they're laying down on its side. And because of that, the batteries weren't able to recharge through solar panels that were on the ground side, right, facing the ground. So after less than a day, they ran out of power. So obviously they're looking at what went wrong on both of those missions to try to correct that as well. And I'm sure they'll figure out what happened and they're going to correct it. So my point is, if you look at this list, right, 2 out of all of those have actually made it successfully to land softly on the lunar surface, upright, and complete mission success. We're going to do the next one in December of this year. This is Griffin Mission 1. Like I said, this is the largest commercial lunar lander to date that's going to go. I mentioned we're going to deploy a commercial rover called, it's actually called the Flip rover by Astrolab. And you can go online and check it out. It's pretty cool. The whole intent here is we need a medium-class lander to take heavier payloads to the lunar surface. Peregrine, our first one, was a smaller spacecraft, and it can take instruments, carry about 150 kilograms. This lander will be able to take up to 500 kilograms to the lunar surface. Well, you're probably saying, so what's the big deal about that? Well, taking rovers, taking oxygen production units, there is a effort that is hopefully, depending on the budgets with NASA, going to fly a prototype oxygen production unit where you actually can scoop up the lunar soil. You put it into this, basically, I'll simplify the mechanism, heat it up, and some of the byproduct of heating up the lunar surface regolith is oxygen. And so if that proves out, which it has been used with lunar simulants here on Earth, now we're starting to look at how do we produce oxygen for breathing air. We know that there's water ice at the South Pole. That's why there's a big focus on the South Pole. If we can get to that water ice and drill it and excavate it, we can break it into drinking water, oxygen, oxygen for the other one part of the rocket fuel equation. So you don't have to take all the propellant with you. You might be able to produce it right there on the surface to come back with. So potential is really high there. And I said we're right on the cusp of starting to do all that technology development. I mentioned before about landing autonomously. I mentioned how Griffin is going to be doing that. We've done some testing with our hardware out in Mojave. We continue to refine it. And that's what kind of the hazard detection system is going to enable Griffin to avoid craters, to avoid boulders and so forth like that, so that we have a good landing spot for our commercial customer so they can roll their rover off and actually do some exploring with it. So I'm going to talk a little bit about the communications energy. What's the difference between the moon and Mars? Obviously the moon's a lot closer, right? So the delay in getting a command signal to a lander or to a rover or whatever you have on the surface is a matter of seconds. And so you can always get that reply typically back in a matter of seconds. That allows you a little bit of time to react to different things, right? Mars is a completely different story. Mars, it takes minutes, like 6 minutes, for a command to get to, say, the rover on the moon, or excuse me, on the Mars. So if you're waiting, you send a command for 6 minutes, and then you got to wait 6 minutes for it to verify that it got it. That's 12 minutes, right? If you're cruising around on the surface of Mars and you're about to run into some hazardous area, that's way too long to be able to react to that, right? So there is a lot more autonomy built into the rovers on the surface of Mars because of that reason. That's what's pushing more AI towards space, is to be able to do these kinds of longer distance missions autonomously, right? And we're going to need that before the human missions start as well. We need that autonomy to be, and the AI, and quite frankly, the machine learning to be able to do that. Data is limited on the surface of the moon. Believe it or not, there is limited data on the surface of Mars. We haven't been all over Mars. We've been in certain areas. So much more data is needed there before we can really get good at being having autonomous systems on the surface of Mars. So I've talked a little bit about AI, right? Autonomous versus AI. We're definitely in the autonomy phase. Because of the environment that I described to you, it's hard to have what I call hardened systems to be able to survive all of those extremes. Everybody is working on to make those systems more reliable so that we can actually move from autonomous to more AI-driven type platforms. Computational resources, this is a key one. Everything you take with you, that's all you've got. So when you've got a solar panel to recharge your batteries to keep power on the lander, that power is also used to power the computers, to the transmitters and the receivers that are sending commands, receiving commands, so forth like that. All of that is based on the batteries that you have on board. So it's limited. It's not unlimited. Once we get those lunar electric grids on the lunar surface, that opens it up even more, though, so that you're going to have more computing power. You can actually do it right there on the moon. So there are a lot of challenges that we're still working on to overcome, but I'm seeing progress, not just with Astrobotic, but throughout the industry on how to improve that as well. Busy chart, I know, right? What's my key message here? Well, this was a report that came out in 2023 that talked about what the global space economy is worth. And that was 2 years ago, $384 billion. This is all of space. This is commercial services and low Earth orbit. This is all the way out to the lunar economy that we're trying to start as well. $384 billion. All of the reports I've seen, all of the analysts are still predicting that this is just going to continue to grow. So my point here is, here in the tri-state area, when I say tri-state, Pennsylvania, Ohio, West Virginia, if you looked at what we contribute compared to like the other aerospace companies that are located in California, Colorado, Florida, the tri-state area combined equals all of those other aerospace locations as well, which is pretty incredible. And we're seeing growth. As you can see on the orange bar, that shows growth in Ohio and Pennsylvania and even West Virginia. We're focusing on that through the Keystone Collaborative, if you've heard of them, and I would encourage you to go out there and Google them if you haven't. But it's really a consortium that is focused on the tri-state area to really increase the number of aerospace jobs and bring in additional business into this tri-state area. We work with West Virginia in a lot of ways in the software world. Ohio, there's the Glenn Research Center. It's a NASA center that we go to test our spacecraft. And they have a lot of expertise there in space power. And this is just going to continue to grow. It's a really good partnership between the three states. And we'll continue to see growth, I think, in these three states. One other fact, too, I wanted to mention. Griffin, the spacecraft that we're building now, I think the statistics, if I have this right, 512 out of the 514 manufactured parts have all been built here in Pittsburgh. That's why Astrobotic got started here. They're taking advantage of the manufacturing capability that got started here back during the steel industry and still exists today. And that's why it's a great area to have an aerospace company, because we can do it all here in Pittsburgh or in the state of Pennsylvania, or even expand out into that tri-state area, which is awesome. That was another reason why I came here, was to help that growth here in Pittsburgh. One other shout out to the Moonshot Museum I mentioned. It is a museum that is attached to the Astrobotic facility. You can see in the upper left, that's a shot from within the museum, looking into the clean room where we were building the Peregrine spacecraft, and you can now see us building the Griffin spacecraft. As far as I know, we are the only company to do that, to allow access to the public, watch us build our commercial lander. So it's really unique. If you haven't gone there, you need to go there. The Moonshot Museum is an awesome experience. It's a nonprofit. I have seen just tons of kids come through at various grades. It's a very interactive museum, very educational. The staff there are fantastic. And even the Astrobotic staff, including me, actually give talks there occasionally to the various groups that come through. So again, I'd encourage you to go to it if you haven't been, or go back again if you haven't been there in a while. So with that, I hope I've left with you kind of what Astrobotic does right here in Pittsburgh, how it impacts the overall space economy, our involvement in where we're going with the lunar economy. I expect we're going to see more growth. I know things are at chaos right now. I talked to my former NASA colleagues a lot about the chaos that's going on in DC. Taking a step back though, there's a lot of emphasis for commercial companies, particularly in space. So I'm going to continue to see growth, I think, in this area. I think there's a high potential for us to continue. You're going to see more shots on goal going to the lunar surface. And it's just going to be exciting, so stay tuned on that. So with that, thank you.